In today's lesson, we're going to be talking about adding and subtracting polynomials. So we've got quite a few goals. We want to be able to identify the parts of a polynomial, the degree of a polynomial, and then what's in the title of the section, which is add and subtract the polynomials algebraically. So in this section, we've got some vocabulary that is really important that we pay attention to. The first two learning goals here both have to hinge upon you knowing that vocabulary. So we've got all of these definitions here that are going to be really important for you. So we're going to be talking about polynomials for quite a while from this point. So a polynomial is a single term or the sum of two or more terms with whole number powers, meaning all the exponents have to be whole numbers. Remember, whole numbers start at 0. So 0, 1, 2, etc. So that means in order to have a whole number power that you cannot know exponents that are fractions decimals or variables. So whole numbers in our exponents in order to be a polynomial. Within a polynomial, we have coefficients, which this term you should already know. It's the numeric part of a term, so the number that's in front of your variable. The constant term is the term that doesn't have a variable at all, and that's because it has a degree of 0. So it's like having, when you have a plain old 5, that really is kind of like 5x to the 0. So it does not have a variable attached. The degree of the term is the sum of the exponents of the variables contained in that term. So most of the polynomials we are going to be looking at, each term only has one variable, and so then the exponent that there would be the degree. Now, that's the degree of a term. When we're talking about the degree of a polynomial, that's just going to be the greatest degree of any term. So in Algebra 1, this is just looking for the highest exponent. So you're going to look at all the terms in your polynomial, find the highest exponent. That's going to be your degree. We have a specific way that we have to write our final answers when we are doing operations with polynomials, and that is called standard form. Standard form of a polynomial is when the terms are in order from the highest to the lowest degree. So meaning highest exponent to lowest exponent. Which means that usually the lowest exponent is a constant if we have one. The leading coefficient is the first coefficient when it's in standard form. So if it's not in standard form, you have to look for the term with the highest exponent first, and then it's the coefficient of that term. So find the highest degree or the highest exponent. The coefficient of that term is called your leading coefficient. We have special names for certain types of polynomials. So if a polynomial just has one term, for instance, 7x would be an example of a monomial. One term, that's all I've got. A binomial is when we have two terms. So maybe instead of just 7x, it's 7x minus 5. That would be a binomial. A trinomial has three terms. Now, the terms can't be like terms, otherwise we would combine them. So an example of a trinomial might be x squared plus 7x minus 5. Three different terms, none of which can be combined. All right, so we are going to look at some examples of using these definitions, and I'm going to go through a few for you, and then I'm going to have you try some things. So, example 1, circle the expressions that are polynomials. If they are not, explain why they are not. If they are polynomials, write them in standard form and identify the degree, the leading coefficient, and the constant term. So, first job is circle the expressions that are polynomials. So polynomials, all of the exponents have to be whole numbers. So starting at 0, getting bigger, no fractions, decimals, or variables. So this first one is not, because this exponent is a negative number. So that's lower than 0, so this is a no. So this I'm going to write not, because -2 isn't a whole number. This next one, exponent here would be 1 if nothing's written, 2, this is an exponent of 0, so yep, those are all whole numbers, so we can circle B. C, exponent of 0, that one's good. Exponent of 1/2, that's not okay. Not a polynomial, because 1/2 is not a whole number. So has to be a whole number in order to be a polynomial. Right, this next one, 23, well, I don't even have any variables, which means that I don't have any exponents, because remember that the exponent on a constant term, this is like saying 23x to the 0 power, but 0 is a whole number, so this one is a polynomial, even though it's just a constant. And then E, okay, exponent here is 5, that's a whole number. 3 is a whole number. The exponent here, when nothing is written, is a 1. So yes, this is a polynomial. All right, so now that we have identified which ones are polynomials, the ones that we circled, we need to go through and identify the degree, the leading coefficient, and the constant term. So, degree, again, you can go back and look at the definitions if you want, but the degree of the polynomial is going to be the highest exponent. So, in this polynomial, this exponent is 1, 2, and 0. So, 2 is the highest, so it's degree 2. The leading coefficient, remember, is the coefficient of the highest exponent term. So if the highest exponent was 2, the coefficient of that term is my leading coefficient, which is 4. Oh, I almost forgot one of the things. I forgot to write them in standard form. So standard form means highest exponent to lowest exponent. So highest exponent was 2, so 4x squared. After x to the second power should come x to the first power, which is this term. So we'd put plus 6x, and then all the way down to our constant, which in this case is 2. So 4x squared plus 6x plus 2 would be the standard form, which then makes sense because the leading coefficient, it tells us if it's in standard form, it's the first coefficient. So standard form 4, leading coefficient 4, that matches up. The constant term, remember that your constant is the one with no variable attached. So that would be our 2 in this case. So these would be all of our answers here. For D, standard form is just as is because there's no other terms to arrange. This happens to be a monomial. Its degree is 0. And we know that a couple different ways. One way is that we're told right here that a constant term has a degree of 0. The other way that we know that that's true is because this is like saying 23x to the 0 power. So degree 0 for all constants. The leading coefficient is the only coefficient, which is 23. And the constant is also 23. So when we only have a constant of our 4 answers that we give, 3 of the 4 happen to be 23. All right, last one of this type. So this one already happens to be in standard form because it already was highest exponent down to lowest exponent, which in this case, my lowest exponent is a 1. So the thing I want you to do next is to identify the degree. So look at this polynomial and choose what the degree is. Again, the greatest degree of any term, looking for the highest exponent. So go ahead and select the degree of the polynomial in part E. So hopefully you said that the degree is 5 because that is the highest exponent that we see in here. So degree of 5 here. The leading coefficient, which I'm just going to abbreviate LC, is the coefficient of the degree 5 term. So in this case, my leading coefficient is -3. And then my constant in this case, well, I don't have one. There is no plain number, which means that that plain number was 0, because we wouldn't write a +0 on the end of a final answer. So that means our constant was 0. So get some separation around these answers, and hopefully those help make those definitions make more sense. Example 2, still definitions, this time using the special names. So we are going to label each of these as a monomial, binomial, or trinomial. If it doesn't fit into one of those special names, then you're just going to write polynomial. So looking at A, these are based on the number of terms. 1 term, 2 terms, 3 terms. This has 2 terms. So that means that this should be a binomial. Neither of them were like terms. All right, and this next one, I don't have any like terms either, and I have 1, 2, 3, 4 terms, which up here isn't in our list. So it tells us in the directions, if it doesn't fit into one of the special names, just write polynomial, which is what we do here. All right, C, this has just 1 term, so that means this is a monomial. And I want you to go ahead and do the last one. So decide how many terms it has, just like I did in A, B, and C, and then choose either one of these 3 if it fits into those categories, or if it doesn't, choose polynomial. All right, so this has 1, 2, 3 terms, which means that we should call this a trinomial. So hopefully you got that right. If not, hopefully that answer makes sense to you now. All right, example 3, add the polynomials. So when we add polynomials, all it really is combining like terms. So there's the horizontal method and there's the vertical method. I'm going to show you both. I don't care which way you choose to do the problems. It's always going to be your choice, so you can just decide what works best for you. So the horizontal method, all I do is use something to identify the like terms first. So usually I either color code, so if you have highlighters, you could use those, or I do like underlines and squiggly underlines and circles and things like that. So X, this is a plain X term. So another underline I would give to any other plain X term, which I see right here. My next term is a constant. So if I make my constants squiggly underlines, that means any other constants would also need a squiggly underline, which this one happens to be a constant as well. I've identified all my terms with some kind of marker. When we write our answers, it tells us standard form, so highest exponent to lowest exponent. So we're going to do the x's first. X plus 2x is 3x. And then my constants, -2 plus 5 is 3. And so that would be my answer using my horizontal method. I'm going to show you the horizontal method again. In this case, I'm starting out with a squared term. So if I make that my underline, now I just look across for any other squared terms, which I have one right here. Next, I have plain y terms. So I don't have any others of those. And then I have constants, which I'm going to circle right there. Standard form, highest exponent here is 2, so I start with those squared terms. 2y squared plus 3y squared is 5y squared. Then my plain y's, this doesn't have a like term to combine with, so it just stays as is. So I bring down my plus 3y. And then finally my constants, which are circled, +6 plus -4 is +2. And so that would be my answer. You can also do these types of problems in a vertical format, which would involve lining the terms from your second polynomial expression up underneath their like terms from the first one. So I would put this -x squared underneath the x squared. I would put this -4x under the other x term, and then this -6 underneath the other constant term. And so remember that -x squared is the same as -1x squared. So I have 2 minus 1, which is 1. So just plain x squared. We don't need the 1 in the final answer. Then I have +3 plus -4, which would be -1. So minus x. And then +9 plus -6, which gives me +3. So x squared minus x plus 3. Remember to make sure that even if your originals aren't in standard form like these ones were here, that you need to put them in standard form. So I'm going to go ahead and do that here. This first one is not in standard form, so I'm going to do x squared minus 3x plus 5. And then plus -3x squared plus 2x plus 4. So this one I want for you to do on your own. Go ahead and use either format. Does not matter to me, but you need to make sure that you select the correct final answer that's in standard form. All right, so regardless of whether you're going to use a vertical or horizontal format, you should get the same answer. So since I only did vertical once, I'll do that one again. So lining up the like terms with each other, which this is like a 1. 1 minus 3 is -2, so -2x squared. -3 plus 2 is -1x. And then 5 plus 4 gives me 9. So hopefully you decided that your answer is -2x squared minus x plus 9. And remember, totally fine if you don't care for the vertical format, you can certainly do your either color coding or underlines and squiggles and whatever the case may be. All right, example 4 is an application, so it's just showing you a situation where you might need to use polynomial addition because here we're trying to find the perimeter. And perimeter means add up all the sides. So we're doing 4x plus 8x minus 14 plus 6x plus 10. And when it's all addition, I can say, okay, x terms I'm going to underline. Then constant terms I'm going to squiggle, and that's all of them. So then 4x plus 8x is 12x plus 6x. 12 plus 6 is 18, so 18x. Then I've got negative 14 plus 10, which is negative 4. So the expression for the perimeter would be 18x minus 4. All right, last examples. Subtract. Write your answers in standard form. Now, remember, when you are subtracting, what you're really doing is adding the opposite. So what we are going to start with, no matter which way you prefer to do the problem, you are going to make your first step to distribute the negative 1 and get rid of the parentheses. So you're going to copy the first polynomial. You're going to distribute the negative 1. So negative 1 times x is negative x. Negative 1 times 7 is negative 7. Once you've distributed, now it's just like adding. Say, okay, underlines, squiggles, 5x minus x is 4x, negative 5 plus negative 7 is negative 12, and we're done. So it's really just like example 3, except we have to distribute this negative first. So I'm going to show you another here. So first step, take away the parentheses. So just write my first terms from the polynomial as is, and then distribute this negative 1 to all terms of the second polynomial. So negative 1 times negative 5x squared gives me plus 5x squared. Negative 1 times negative 2x gives me plus 2x. And negative 1 times negative 9 is positive 9. So x squareds, x's, and constants. So standard form answer, so x squared should come first. 2x squared plus 5x squared is 7x squared. 3x plus 2x is 5x. And then 2 plus 9 is 11. All right, so next I want you to try it. So same thing that I just did here in A and B, I want to see you do the same thing in C. So remember, this is like a negative 1 in front, so you're going to recopy these terms, distribute your negative first, and then combine those like terms to get a standard form answer. So go ahead, write out all your work to do that, and then select the correct choice. All right, so let's check your answer here. So as I told you, we've got to recopy this first one, then distribute our negative. So negative 1 times 4y squared is negative 4y squared. Negative 1 times negative 9 is positive 9. So now identify your like terms. So here are two different y squared terms. I only have one plain y term. And then here's a constant. Here's a constant. So standard form answer starts with the highest exponent. So this is 1y squared minus 4y squared. So that gives me negative 3y squared. I didn't have another plain y term, so that just gets brought along. And then 8 plus 9 gives me 17. So there are all my terms in the right order to give me my final polynomial. All right, on this last one, I just want to illustrate for you that you could also use the vertical method. On this one, notice that I had two x terms in the same polynomial, which means those need to be combined. So that gives me 17x for my first polynomial. When I distribute the negative here, that gives me negative 8x plus, or no, not plus, because minus and a plus is a minus, so minus 15. And then negative 1 times negative 7 is positive 7 for the x squared. So you can distribute first if you want, and then line them up underneath each other if you want. So I can say, okay, this 7x squared, I'm going to move underneath here because that's a like term. This negative 15 doesn't have anywhere to go, but this minus 8x, I could move under here. And so now you could also do this vertically if you wanted. So 14 plus 7 is 21 for the x squared. And then 17 plus negative 8 gives me 9 for the x term. And then my negative 15 doesn't have a like term, so it just gets brought along. So just want to point out to you that if you prefer a vertical method, you could certainly do that here. If you can't tell, prefer the horizontal method here. I just think it takes less time, but both are valid. Whatever makes more sense for your brain is what you should choose to do on your paper.